and thank you everyone for joining. Great to be with you this afternoon. I hope you've got a really exciting discussion. Anthony Greer from TALO will do a presentation shortly, and then I'll ask a couple of questions and open up for more Q&A. So do ask your questions in the chat, and we'll try and make sure we cover them. Just with a few words of introduction for those that don't know me. Uh, Nigel Banks, I'm Technical Director at Octopus Energy. I lead on our work on decarbonising housing and largely working in new build to date, working with house builders. And I thought it'd be worth just sort of 60 seconds at the start on a bit of context from today's Committee on Climate Change Carbon Budget 7 report and how that perhaps feeds into the discussion today. So hopefully some of you may have looked at that. If you haven't, it's definitely worth having a look, or reading the summary that Carbon Brief put out, which is excellent. I think there are a couple of key headlines that came out to me. One, hopefully, the argument over heat pumps versus hydrogen or electrification versus hydrogen is hopefully dead. They'll come out very clear that there is no role for hydrogen in heat in buildings, and electrification and heat networks are the answer, which we strongly support. Also, a massive upscaling of solar, battery, and wind and smart controls are required to decarbonise the economy. Initially, decarbonise existing sectors, and then as we electrify transport and heat, need to increase and it is quite staggering volume, sort of 5 times as much solar, 5 times as much battery, 5 times as much wind as where we are today, and doubling that often in the next 5 years. The one interesting bit which I have previously spoken on, which I find interesting, is they've come out with a very limited view on deep retrofit and a support for sort of limited or extensive low-cost interventions, but only 15,000 homes need solid wall insulation by 2050 in their balanced pathway, which is I find quite surprising and staggering. But a really clear view that new homes need to be very energy efficient, and new homes need to be on electric heating systems, whether that be heat pumps or direct electrical systems. So, and I think we also have lessons to learn from other countries that are doing this well. So one of the big things that is pointed to in the report is other countries have accelerated the adoption of heat pumps much quicker. A lot of that's been in new homes. And one of the countries that is looked at is the Nordics. And today we're going to hear from Anthony and some of the lessons and the technology that they're bringing from Finland to the UK. So I will hand over to you, Anthony, if you want to share your screen and give questions, and just a reminder to add questions in the chat, and we'll pick that up from there. Over to you, Anthony.
Great, thank you, Nigel. I hope you can see that screen now. Yeah, so I guess I'll start with so it was minus 29.5 degrees Celsius, and I'd just driven for 2 hours through this forest, and the last pub, the last restaurant, the last shop I saw was 2.5 hours ago. It was snowing pretty horizontally, and I stepped out of the car in what I thought was all my warm gear, and I was so cold. I was cold through to my bones in my knees. I remember my knees aching within seconds. And then the gentleman I was going to meet, called Sampo, he stepped out of the building to welcome me and walked across the icy car park with an open hand to shake my hand, wearing light coloured chinos and a short, what I could only see as a short summer shirt, a short sleeve summer shirt. And that was kind of my first indicator, things that might be a little bit different here. And it carried on. This is kind of the beginning of my journey of really getting my head around a different mindset. We were talking at that trip about a project we were looking at, which was a house for autistic adults to live in. And there's one room which was sort of the breakout room where they can go in with any anger and thrash around and you wouldn't damage it. And it had a really high specification for the walls, so they couldn't be damaged when they were being hit, etc. And I went to the guys at the factory and said, "Can you do this really high specification plasterboard for the walls?" And they looked at me with this face of utter confusion. "All our walls like that, aren't yours?" And again, it was this sort of different view on how you build houses, which has been driven by drivers for many decades in a very different place and direction. And that's when I realized there was a real opportunity here to do much more than just provide homes, but look at how we can do this quite differently. So sort of a bit of background on Finland. So I was in northern middle Finland, which is where the factory that produces the houses, this house system we use, is based. And about 70% of new homes in Finland are prefabricated offsite. It's the norm. It's just how houses are built. And you don't actually sit there and go, oh, should we do an offsite manufactured home? You say, what outcomes do we want from our project? What would we like to see in terms of energy performance, quality, and all the other drivers that get you to it? And it seems a very evolved market. And we started exploring, well, how did it get to this place? And what were the drivers for this market to go 70% off-site when in the UK we're only just really starting our journey in earnest? And there's some obvious drivers, like I've alluded to. So the climate there can be brutal. So in winter in the north, it can be like minus 50 degrees Celsius outside. But interestingly, in the summer, down in Helsinki area, it can be plus 30. And actually the temperature profile of that area is very similar to Cornwall. So it's curious when you see things come out of that the concept that we now have of overheating, which is only relatively come into our regulations as we become more energy efficient with our homes, has been an issue there for decades and resolved many years ago. And then the other big driver is, if it's really cold outside, you do not want to be working outside for any longer than you really have to. And you don't want to be using wet trades because everything freezes and it just stops everything from working. So we've seen some different priorities and different ways of operating. The other differences we've seen are within the market. So they don't really have the large development projects that we see, 1,500, 200 homes done by a big PLC. There's so much land there and relatively few people. But actually a lot of the developments is one house over there, two houses or five houses. And often the people building the houses will have a lifelong connection with what they've just delivered. So we're seeing that some real priorities have come up through, it has to be design flexible. Pretty much every project is bespoke. But the price pressure is just the same. So they've had to develop systems that allow you to deliver super low energy homes that are design flexible, but still cost efficient. So we contrast that with the UK market. There's a whole series of drivers, and maybe the drivers are slightly different, but actually they bring us to a surprisingly similar place. So, these are well-known challenges, nothing to do with us, just the way the market is, such as skills shortages, risks, cost of material, productivity, are challenges within construction. And then there's an ongoing demand for more homes were required. There's a cost of living crisis. The cost of living is really hard. There's a real issue in many people having to decide whether they should heat their home or whether they can eat due to living in fuel poverty. Rising energy costs, and on top of that, there's a drive to get to net zero. And we've seen actually this brings you to a place where what it works so well in Finland actually has a wonderful place, we think, now in the UK. So TALO is we founded TALO about six and a half years ago with two of my co-founders. There's Leona, who's Finnish, has worked in offsite manufacturing in the Nordics for a long time. Ben, who's Norwegian, and also built his first home 30 years ago in Norway, but also has experience of mega yacht manufacturing and oil and gas. And then my background is as a geophysicist, working globally in oil and gas markets with in the scientific community and also operations. And the three of us have brought this system to the UK. And it's a category 2, so closed panel timber frame solution. And it delivers ultra low energy housing. And I think what matters a lot to us, and we think it's a lovely way to work, is everything's driven by our mission. Our mission as a business is to provide an alternative way of providing homes where you just never, the occupants never need to have an energy bill again. And that itself just ensures there can be no fuel poverty in any of these homes. So the homes are super, super well insulated, exceptional low air tightness, of course, with mechanical ventilation, heat recovery throughout. And that puts us in a place where typically we exceed the thresholds to be considered a passive house energy standards. We typically exceed that by about 25%. So your energy use to heat the house is so minimal. We find we're in a position where actually to make a house an energy generator, so the house generates more energy than the occupants use, you can be in a position where you just use solar, some battery, and then direct electric heating. And that actually has further benefits outside the superstructure, because you now know how your maintenance of gas is gone, maintenance of air source heat pump is gone, and the only real maintenance you're doing is an annual filter change, which is now de-skilled and cheap and easy to do. But again, under that mission, it's pointless us doing this if our houses are too expensive, because they hold incredible quality throughout. So the windows are timber triple glazed window with aluminium clad on the outside, so they're maintenance free. The doors are gorgeous. They weigh about 100 kilograms, super low energy. And as I mentioned before, I touched upon the up-specking of everything within inside the house. But unless we can make this cost competitive in the UK market, it's kind of an irrelevant hobby, because no one will buy it. We won't achieve our mission of providing an alternative way of removing energy bills. So what is lovely is the system's been evolved over the last 47 years. And it's delivered about 30,000, equivalent of about 30,000 UK homes across the Nordics. And throughout that evolution, it's been industrialized, the process, to reduce costs as well as maintain that quality. So I just want to show a very quick video. What we'll see is the construction to wind and watertight of 6 houses in 10 days. And the team to do this is 2 people and a crane operator. So there's a day ticker on the bottom left, and the wall sections are very long. They're the length of an articulated lorry, not the width. And the windows and doors are installed at the factory. The wall is complete. In this case, it's a timber external fascia. If it's render boards, put the render backing boards on. If it's brick slips, we prepare for brick slips. And the wall's complete all the way through to the internal plasterboard. We're now on day 8, and we can just coming around day 9 and 10. We complete the 6th house. Sorry. So that's 6 houses installed to wind and watertight within 10 days using 2 people. So it's actually a very scalable solution and can actually transform the development program of a larger site. This mission-driven approach, though, affects almost every part of the fabric. The installation is almost a nice visualization of that. But the design process, we will design optimization of costs as well as fitting the design. But there are choices made in there. And if I go back to that robust plasterboard, that's more expensive. It's then teamed, rather than for the internal light walls, we don't use traditional studs. We use LVL, laminated veneer lumber, which is way more stable, doesn't twist, doesn't move, and you can make your walls thinner because you've got high performing acoustic plasterboard on there. So you now outperform your acoustic performance, you outperform your quality and durability of your wall, and you've now just created more living space in every internal room. So it's more of a holistic view going to an outcome rather than being tendered or specified to an employer's requirement or to the lowest cost. And you see this through the offsite in the manufacturing process. The airtightness levels we get are incredible. Down, we guarantee 0.6 cubic meter square per meter cubed, but we typically deliver to 0.18. But what really matters is we're doing sealing up with this incredible tape, but putting that on carefully and putting that on slapdash makes a massive difference. How do we get people to care about that? Well, they buy into the mission of eradicating fuel poverty. They're going to care about that way more and be proud of achieving that far more than making us more money as a business. And then reduce work on site. We do have a skills shortage, but this model works really nicely in using relatively few people to install houses quickly, but still allows the trades then to come in afterwards and integrate with the local community. So this is the incredibly cold at the time, but it's nice and sunny here, the production facility in Finland. And actually we'll be replicating this with factories in the UK. And the only bit we actually need to replicate is the L-shaped building in the middle. In the north, it's in the top of the picture, it's a sawmill. It's one of Europe's most advanced sawmills. And what's important to pull out of this is there's no waste anywhere. Everything's recycled. And there's no timber stored outside once it's been dried. So once it gets dried in the biomass kiln, it's then manufactured inside. And because the timber is dry, it doesn't want to twist, warp, or move. It's really, really hard to buy dry timber in the UK. The supply chain just doesn't recognize it needs to stay dry, which then means if I was to go and buy a timber frame kit from a UK supplier of how they normally do it, it costs about 10 times as much because there's an awful lot of stuff in there holding the timber straight when it wants to bend. And you have to use OSB on it to fix it straight, where actually we don't. So this dry chain goes all the way through the process of the manufacturer. We then reverse the trucks into the factory. We then load, and it's curtain covered trucks. So they arrive on site dry. And then when they're installing, like you've just seen, everything is covered and protected from the weather. Then a day and a half later, it's a wind and water time. So you now have a superstructure that doesn't want to move. It doesn't settle. It's stable for the life of the building. And that's a great foundation now to take this culture of aiming for excellence and zero snagging into an environment where it won't shift and move. You don't need to go back and repair all the cracks. So I guess our journey is one of learning about this industry, learning how this amazing product fits into the UK. And there's many challenges within this industry we have to address. And it's not just buy my product, it's understanding how it fits in. And I've touched upon a few of these as we've gone along, but being that design flexible, being at cost parity, and exceeding regulations rather than just trying to meet them starts to give us that platform to do so. So we've done about 60 units so far in the UK, and we're very pleased we're scaling now. And these are just some examples of some of the projects we've done or are doing. Top left and top right both have different variations of dormers. They don't exist in Finland. They've got loads of space, so they don't need to live in the attics, and culturally they just filled the roof with insulation to have a cold roof. So that took some working out, because how do you make a dormer that is equally energy efficient as the rest of the house superstructure and not ruin your energy performance? And we're learning about how various different parameters are important to various different people. This is a quote here from Frankham, recognizing one of the biggest benefits to them was actually project certainty. If we're due to turn up at 7 a.m. on Monday, we'll be there at 7, not 6:59, not 7:01. It'll be 7, and we'll finish exactly on time, and you can book on that. And the business model looks a little different in terms of the factories. So the factories are really quite small. They can deliver about 1,000 homes a year. But this allows us now to go onto a model of regional factories. The first factory will serve the nation, and then we'll start stepping out into regional factories, which puts us closer to our customers. It means local employees delivering homes to the local region. Every factory will have a TALO Academy on it, which will train not only our stuff, but it'll also train the local plumbers and electricians, who then get to customize to work within our superstructures. And their life is way easier in a warm, dry, and millimeter precise superstructure designed for them to come in and do their job effectively. The capital cost, as I mentioned, of the production line of the factory is much lower, make it as a much more sustainable and robust business, which I think is important to give people the confidence and trust that we'll be there to deliver their projects for them. We've had some other reflections, which is really interesting. So a gross oversimplification, but on the left, this might be viewed as a traditional contracting model where the client with the architect do a super project plan, and then it requires a principal contractor. So there's a tender for that, and then they require timber frame maybe, and there's a tender for the timber frame. The only influence that timber frame provider can have is to reduce costs, is to cut quality. It's really hard to influence and have innovation and driving for excellence within that structure. In Finland, and also in my previous career in oil and gas and science, it's a much more collaborative way of working, where there's a shared vision for a project. We sit around with the key stakeholders, so the architects, the clients, ourselves, principal contractors, and together everyone brings their best ideas, their best work to achieve this vision. And that is a space where innovation can flourish, where new ideas can be taken on and tested in a safe environment. And that's something what we really enjoy working within and have found it to be really successful. But not everyone typically works like that. So I guess one of our final points is the mission driving everything we're doing to eradicate fuel poverty, fuel bills. We actually need to share with people because it influences all our stakeholders. And it's far more fun to be working with people who say, actually, we aligned with that. We really like that mission as well. And it's exactly what we're about. And then let's work together. For many people, we won't be appropriate because that might not be their priority. And actually working out who's the best parties to work with not only is successful, but it also puts you in a really enjoyable space to deliver projects. And here, this is part of the reason why I'm excited to be talking today as part of Mesh's webinar series. Is there a great example? We've been struggling to find parties who could take the degree of energy performance we have within our superstructures, model that correctly, and then get their heads around the energy strategy, which was different as well, and do that cost efficiently, correctly every time. And so many times it was coming out wrong and taking too long, costing a fortune. Mesh are far more digital focused. They were already way down this thinking pathway. We've invested time with each other, and we're now really comfortable that they are accurate and correct results. They deliver quickly and they're cost efficient. And it's a lovely example of two parties sharing a mission and working together to deliver something significantly better than was achieved alone. And this is just a little shout out and reflection on some movements we've seen in the market where nothing to do with us, the 23 social landlords backed by the Welsh government have now had their mission to accelerate delivery of zero carbon homes using specifically category 2 offsite manufactured timber frames. And they've now come out with a pattern book. So I think about 11 house designs. So 11 house design agreed on by 23 separate bodies, which sounds just like a recipe for disaster. But Stride ran this process, I believe. And they reported at the launch a few weeks ago that they didn't have a single argument. And I think it's such an opportunity when you're making choices and decisions on something that's bigger than your own preferences, which is, in this case, their mission to really change the way social landlords provide homes in Wales, has allowed them to get to collaboration and common results. So we're seeing this happen within what might be a more traditional procurement environment, and it's certainly available in other environments of a collaborative way of working, which is fits really well with our model and our mission. So I guess in summary, we're super excited to be about doing this. We're looking forward to expanding and shouting out and saying, this is what we're passionate about. If anyone else shares those passions, get in touch.
Fantastic. That's great. Thank you, Anthony, for that. And do add your questions in the chat. I'll kick us off. It'd be useful just I think Brian's asked this question around in terms of just understanding the build-up of the system, sort of a techie question. So you said it's tip category 2, as in it's panelized, factory-made timber frame. But you just perhaps talk through how thick a typical wall is and what a typical build-up is on an external wall?
Yeah, for sure. So the build-up, let's say from the outside inwards. On the external is whatever face you want. So either timber, which is installed in the factory, or it could painted twice. It could be you want render on the outside, so we'll put the render backing boards on in the factory, and then the local render will be done. Or you might want a brick fascia. So if it's brick slips, prepare for brick slips, and they're locally installed, or brick skin, which will be locally installed. So we're not keen on transporting all the brittle components because you end up with more damaging than good. And then moving in from there's a ventilation gap. And then there's the next layer is if you've got a timber on the outside, it's actually a diffusion open plasterboard that's weather resistant. And that's taped and sealed. And then moving in from that, you go into the stud, which is 175 mil wide. This is a slow grown northern Finnish timber. And that's filled with a Lambda 34 mineral wool. Then in front of that, you have 40 mil of PIR board, and that's a complete envelope around the house. And interestingly, that's actually our vapor barrier and air tightness layer. So every joint in that not only gets taped, but then also gets mechanically fixed with a batten. And it's really nice because we keep the whole structure dry. But even if something did get wet, it's diffusion open outwards. And your membrane is on the inside, which just seems logical. Then there's a service void with then the acoustic plasterboard on the inside. So for, first fit electrics, you just drop the wire down the service void, pull it out of the holes that are already cut for the back boxes. And then on the ceilings, we batten and cross batten them. So it's really easy for them to run it in any direction very rapidly.
Fantastic. And what sort of U values is that achieving? Because that sounds like it's sort of 0.1-ish, 0.15. Do you know what sort of?
Yeah, we have a couple of models, but the ones we need for the UK about 0.14.
Okay, fantastic. So, and I think the other key bit which people struggle with bringing new systems to the UK, and we've seen that, and I've been through that, is the accreditation journey. So it'd be interesting, I think, perhaps just to touch on where you've got to with UK accreditations and challenges that's brought. And clearly you built some homes, so must have got warranties, etc. So it'd be useful to get your reflections on that, and I've definitely got some experience of that. But yeah, it'd be interesting to see how you found that.
Yeah, so we recognise again you just need to do that. So we've gone down the route of getting system approval. So originally we did it with LABC warranty and Premier guarantee, and we now do it with ICW warranty. So using the top 5 guys. We've also been on a process now with NHBC, which I think we're about 98% of the way through. It's that final peer review stage. So our aim is you just should have all the box ticks. So as you come along, we're not asking you to be that different. We're just saying you can use it through the systems you normally see. And it's lovely as well because on site, because they've been to the factory, because they've reviewed all our quality processes, because there's a complete manual of everything we do. On site, the actual job of the inspector is this building what should be built? And is it stood up straight? That's pretty much it. So it makes the on-site role really quite smooth. And then we also give the inspectors a manual of what we're doing, which really empowers them to understand what's behind the boards, even though they don't need to know. I think communication and empowering people to enjoy and get into what we're doing is really important part of it.
And then looking at a couple of questions from Les and Richard have come through around the production process. So it says sort of 6 houses in 10 days on site to get them weather and watertight, and then presumably post that there's a period of weeks to finish off kitchen decoration, bathroom fitting, etc. But in the factory, it looked like a semi-manual factory rather than a fully automated line from the pictures I saw. But interesting to understand that, and also Richard's asking around the thought of using production engineers and the training to do what's required on site, doing it the way perhaps the Finns do it rather than the way that site management on British sites might say, oh, that's the way we do it over here, and addressing that barrier.
Yeah, so there's a few questions there. So you saw the size of the houses in that little video. So on that production line, which is manual, there's only really one automated tool, and that's the 5-axis saw, because your timber's straight and you get your cuts perfect, everything else just flows. But we'll manufacture a house before lunch. It's really quite an efficient, rapid process, even though it's manual. But it's back to that industrialization point. Industrialization doesn't automatically mean lots of robots. It means process and understanding how to do it correctly and efficiently. So that gets that done really quickly. Yes, on site, once we've got to wind and watertight, we then have our second team. So these are all TALO people who then come in and take it to airtight and put up the internal walls and finish off the insulation. You saw the roof is roof trusses, that needs insulating on the inside. So there's another couple of days of work sort of there. And then I think there's a huge opportunity here. Maybe this is what Richard is alluding to, I'm not sure. But to look at this slightly differently. So the part about the TALO Academy is the follow-on trades are not within our control. But we can absolutely support people to come in and learn how to work more efficiently in this way. And I think that's a much more healthy environment for us to be supporting the local businesses to improve their efficiency, their reliability, their profitability, than it is us saying, let's do everything ourselves. It's more scalable and puts more economy into the local community. So that's kind of our model. Anything we do, we completely control. And then we support before and afterwards to make their development of what they do.
And how have you found on the project so far the bits that are outside of your control, the groundwork, putting the foundations in, the follow-on trades, perhaps deciding that they want to put a cable in a different way and just drilling a hole through your wall and doing things differently. And it's those sort of bits, I think perhaps that's where, managing that side of it can be particularly tricky. And certainly my experience at Ilke Homes was the factory got very good very quick, and the install process got very good very quick, but the interface with the traditional trades and that relationship piece can be very challenging. So yeah, I'd be interested experiences so far, and you think that's largely a training piece, or is there something else that you're thinking that, and perhaps you see differently in Finnish culture, that we need to try and transport to the UK?
Yeah, well, it's a good point, and I'm sure I'm sensing the experiences you had are ones we shared. We've turned up to rather big. So we started this 7 years ago, so we tiptoed through, and we learned early on that the way foundations are done in the UK is very different to the way you do them in Scandinavia, the Nordics. And our experience in our first project was the local way where it had to happen, cost about 10 times as much, created a swimming pool rather than a drainable platform, took 4 times as long. And it was really quite hard for us to understand what was going on. So yeah, I think part of it is supporting them to change. And we recognize that the planning and thought stages within a traditional build are very different locations to what we require. So I think this comes back to alignment of parties who really want to do this with us.
So it's finding the partners that you can work with.
Exactly. Yeah. And if the point of my presentation about saying this is what we're doing, who else is interested, is far more valuable than buy our product because it's cheaper or something, or you're forced to, because you need that engagement. So, we protected ourselves within our system of checkpoints and when things have to happen. But some parties will find that more easy than others. But I think it is about finding that cultural fit that makes that friction as least as possible. But I think also once we find that once someone's been through the process once, I believe the next stage, the next time around, will be much easier for them. And it's as much about what's new and different.
So I want to come on to build costs and energy costs in a second, but there's just a question come through from is it Farita around mortgageability and warranties, and I presume with the warranties you've achieved, have you had any issues with warrantability so far?
So the nice thing about the system approval is mortgageability just doesn't seem to be an issue. So I think with the ICW, they're approved by 95% of the high street mortgage lenders. So people getting mortgages has just been a non-issue. And you think about it, vast majority of the large major house builders actually use a timber frame clad with bricks on the outside. If you go to one of the major ones, it's no different really. It's just much higher quality and a different focus and purpose.
Yeah.
So yeah, so we've had no issues with mortgageability.
And in terms of the factory can do the designs and styles of housing that within some parameters, but like most open panel or closed panel timber frame, it's quite flexible, presumably.
Yeah, it's really very flexible. I think, we don't like circles and curves. There's not a lot of demand for that, round walls. And some spans that are exceptionally large. We try not to use steels ever. We've had to once or twice. But they're quite rare occasions. So in the majority of the houses we deliver, it's a non-issue, really.
Right.
We're able to deliver most things.
And you mentioned cost, and certainly cost was, I think, has been the biggest barrier, partly because the industry, the experience I had is that the house building industry has got very good at bashing its supply chain to get things as cheap as possible. And as a result of that, it is actually extremely cost effective to build a house the way it's built today in terms of material cost. The labor cost, though, has shot up and the labor requirements has shot up. And that's potentially why a lot of the bigger house builders have moved increasingly to panelized systems and are looking at cladding systems and that space. And I think that is shifting to a higher material cost but lower labor cost piece. Is that broadly how your economics stacks up? And are you trying to compete on price with those big guys, or are you trying to target a different part of the market? I guess would be my sort of question.
Yeah, so I guess to your first point, the price, we do use incredibly high quality materials. So yes, they cost a lot. We're incredibly efficient in production and installation, so our manpower costs come down, and maybe some of the economic change that you're referring to has worked in our favour, so that's good. And then we also look at it holistically. So on the capital expenditure, within that, they will include within a project viability the cost of the heating. So how much plumbing do you have to do around the house? Do you use an air source heat pump or gas or electric? All these other secondary things that are knowns that they can choose to come holistically over to what we do. And in that case there, we're finding ourselves to be in cost parity in most places. I think there are still some markets where the wages are really much lower than elsewhere in the country. And I think in those we're still a bit more expensive. But we'll be working to address that over the coming time. But in general, we will be cost competitive with this offering, which gives them all the benefit of the triple glazing, of the better plasticals, of the better doors, all that performance, whilst retaining the design. So I think that's where we see ourselves right now. And it all becomes even more competitive once we're manufacturing in the UK, of course.
Yeah, excellent.
In terms of target market, I guess our passion is to put these houses where they'll have the greatest impact. So if we can work with housing associations, social landlords, that's just an awesome home for these, because we then just take away the cost of energy bills from that community of people, which would be a real big impact. We also see that smaller and medium-sized house builders that fit with us is a great place. We used to, many years ago, SMEs used to build most of the homes, not most, but 30% of the homes. Now it's a tiny fraction. is there a place there with our more supportive offering across not only the superstructure, but the project risk and the M&E and the things that are new and different that we support with, can we help them to excel as well? So I think there are core focuses, and also the private rental sector. If you're now a private rental for purpose building and you're the landlord and you can offer to your tenants zero or minimal energy bills, and your houses are now very robust and set up to survive well as a rental sector, that's a really good value proposition. So another area we're focused on.
Yeah, that robustness of the internal plasterboard is something that I'm aware of, and it is probably overlooked quite a bit. I think let's come on to the zero energy bills, or the very low energy bills stuff, and I think just a reflection for me on that's obviously now my day job is to try and eradicate fuel bills in all new homes, and hopefully taking that into existing homes, and certainly we are on that same mission, which is great. And I think one of the things that I think so far we've talked a lot about the building fabric and the insulation piece, but I think one of the reflections that I often talk to people about is in an existing typical UK home, heating is about 70% of the kilowatt hours that go into a house, but only about 30% of the energy bill. And therefore halving your heat load only reduces your bill by 15%. So you're not going to get to a zero bill by just doing insulation. And you mentioned solar panels, batteries, and electric heating systems. So I'd be interested to get your take on the importance of those and how that's seen perhaps in Scandinavia. I know Norway in particular has gone electric and electric heat and electric cars faster than anywhere in the world. I'd be interested to just see if that's something you saw in Finland, and if you're the importance you think of those technologies, as well as the high performing fabric.
Yeah, I think it comes back to that holistic view. Doing something in isolation often doesn't achieve the goal. You need to put it in with its bedfellows to get to the target you're looking for. But yeah, Norway went very early on electric, partly driven by their conditions. They had super cheap electric, so why wouldn't you? And their electricity has really increased now, but it's still much cheaper than ours. But that gave them a driver to move into this place by trying different things sooner than us. And then the government really pushed prioritized that through their taxation regime, and hence they moved very quickly. So a lot of our experiences is not only from the operations, but it's the lived experiences of my two fellow co-founders who just live in this environment where it's normal. So yeah, our view is, in the majority of cases, if you have, yes, a super energy efficient fabric that's low U values, airtight, and great side value design, the combination that seems to work really well is we have a concrete slab on the ground floor, and that's heated with electric cables in various zones as you see fit for your underfloor heating. And that gives you a controlled thermal mass. So, you open the door and walk out and come back in again, the heat's not jumping up and down. It's a really nice controlled environment. And likewise, the bathrooms have warm floors. Then you've got your mechanical ventilation with heat recovery, which is of course required just for ventilation, so you don't go moldy and you have good quality air, it's fills and all those good things. But it's also a really good heat distribution process. So it takes out of the warm and wet rooms, so bathrooms, but also kitchens. And then it takes it out and recovers 95% of the energy and puts that back into the rest of the house. So you have input and output and it's all balanced. So in fact, in terms of energy input, you don't need any more than that for heating. In reality, there are, depending on the use case and the needs of the occupants, you might have one where someone wants their bedroom hotter than someone else. So you might just put a cheap little panel in that allows a boost and gives that feeling of control. And then in terms of regeneration, we're finding the cost of solar panels has come down so much. They're almost getting to cost parity with slates. Then with a battery, you've now got a battery for electric storage, you've got your hot water for electric storage, and your roof covered in solar panels. You're now at the point where you can usually get to where you produce more energy over the year than the occupants will use. And that to me means you're in a place where you're getting to that carbon negative situation, you're removing energy bills, and you're also in a low capital cost environment, and you're in a low maintenance environment. So an air source heat pump, for example, is a super solution, but I think it only goes part way if you've changed your superstructure. If you haven't, then you do need it. But you've also got maintenance on that, and you've also got a retirement of that product after 10 years, for example, which then needs amortizing on the cost of it, or however long it lasts. So I think as a package, it works. In isolation, none of the components alone stand up.
Yeah. And I think one of the interesting things about the Norwegian market you talked about there is the cost of electricity is a lot lower. And in the UK, electricity costs 4 times that of gas. But it needn't do, and at times of the day, it doesn't cost that much. So I think an interesting fact is the new price cap from April is 7p a kilowatt hour for gas, which once you put it through a boiler, you'll get sort of 8p a kilowatt hour, 9p a kilowatt hour heat for most homes through a combi boiler. Electricity at night on our Intelligent Octopus Go tariff, which gives you 6 hours at 7p. So actually, if you can do that heating and heat up that mass at 7p, it's actually cheaper than a gas boiler doing direct electrical heating. And if there is ability to do heat pumps in and heat up this water cylinder and store that energy in a battery through that nighttime period when typically we've got excess wind on the grid, or you're generating that free from your solar panels on the roof, you can get to an extremely good position. And I think that the bit that we bring to the table as Octopus is the ability to automate that smart control and deliver the smart control of that battery and heating up that hot water cylinder in the most cost-effective way, which isn't always exactly at 11:30 to 5:30 every night. Sometimes it's a still night and it's been a windy day or a windy next morning, and you're better off waiting until 7 in the morning to do that, heat up that cylinder. And that's the intelligent control stuff we do. And I think the other thing which is fascinating, and I think not everyone is fully aware of it, is just how cheap solar panels have got and how cheap batteries are becoming. They're not quite there, but I think I remember installing a 250 watt panel that cost I think £300-400 a panel, and it was silver framed and all the lines across the panels. And now an all black panel that is 450 watts is under £50.
That's what I mean.
It's almost as cheap to install a solar panel as it is to install a fence panel. And in fact, our first zero builds home in Germany that we've done actually has got a solar fence, because the installer, the builder actually was involved in solar installs, and he was more comfortable fitting a solar fence and found it just as the same price as he would have done fitting a timber fence. So the cost of some of these materials has really changed the economics of some of this, and that really is quite exciting. So I'm just going to say, if anyone else got any more questions, we've got about 10 minutes left before we will draw to a close. We've got a question coming from Tobias around government thinking on changing taxation on gas, electricity, lowering the tax on electric and raising it on gas. So, I mean, I started by talking about the Committee on Climate Change, and they have recommended exactly that in their report today. There is a consultation that has closed last year that we're waiting for the government to respond on, which is the review of electricity market arrangements. So the REMA consultation, which the government position was that they were looking to do that, to look at how levies were levied on electricity and gas. But the other thing which we're strong advocates for Octopus is disconnecting gas from being the driver of electricity pricing. So if you look at the chart of the price of gas and the price of electricity, they exactly correlate. And that's because electricity typically sets the price of gas. Sorry, gas typically sets the price of electricity on our system. But in parts of the country that doesn't need to be the case. So actually in Scotland currently has the highest industrial prices in Europe, potentially the world. But if the market was redesigned, we'd have the lowest costs of electricity in Europe, lower than Norway.
Wow.
And that is a massive opportunity for industry to then relocate to Scotland, for some of the new low carbon technologies to be located in Scotland. Why we're fitting data centers in Slough rather than in Aberdeen is beyond me, where we haven't got electricity in place. So it's a really interesting question, and there is a lot of lobbying going on in both directions, I would say. And hopefully we'll find out this summer the direction that the government is taking. So perhaps one last question I think is coming from Simon. It's just around the economics of setting up factories in the UK. How many homes would you need to make to a year to make a profit from a factory in the UK? And clearly that's probably an interesting question. We got that economics wrong at Ilke to some extent. We went too big with the first factory and had to go into a very land-driven, more risky environment to build 2,000 homes a year to get, or 1,500 homes a year to achieve viability in factory one. So be interested to get your thoughts on the scale of factory you need and how many homes you need to make profit.
Yeah, so a single production line factory is quite small. It's only about 30,000 square foot. And it it can deliver 1,000 homes a year. You know, if we take a small three-bed semi as sort of a unit, so about 1,000 of those a year. But it'll break even, cash flow break even at about 200. So it's actually quite a low barrier to being viable. And that's one of the things that allows us to look at this regional model. So, you know, classical economics would say build a big factory, reduce your overheads per unit and improve the economy. But I think behavioral economics says actually put them closer to where the customers are, put them into that local environment and play a different game. So yeah, it's only about 200 homes a year that would are required to make them viable.
And where are you in that cycle of getting to enough volume to make sense? So presumably the first homes that have been built have been manufactured in Finland and transported across. At what point are you looking for factories? Are you thinking of setting up, or are you looking for investment?
Yeah, so
What's the position that you're in
where
now?
we're at in our journey right now is we're just in a process of raising a relatively small amount of capital to allow us to open up the first factory. Once that's closed, it's about a 10-month process before that factory comes into operation. And a lot of that is sending people out to Finland for training and embedding them into the culture out there. This is what we're creating over here. And so, yeah, so let's say about a year away. So next year we'll be producing in the UK in the first factory.
Fantastic. That's great. Well, I think we will probably draw it to a close unless anyone's got any final questions. I think it's been really interesting uh, to hear, and yeah, your opening telling of a story of being minus 29 degrees. I have experienced that once on the top of a French mountain, and yes, it certainly drives you to think about having to do things differently and not want to be outside. And I think the other
Exactly, yeah.
thing which one of my friends I lived with in France was from the Arctic Circle. And yeah, not having light for most of the year or most of the winter also probably drives an offsite push. But we certainly have some pretty awful weather in winter. I know Bristol has rain probably 70% of days of the year, and getting a watertight shell up quickly is a real challenge. So yeah, a really great talk. I think there's people coming in saying really interesting insights. So thank you very much, Anthony. And yeah,
Great.
good luck.
Thank you, Kevin.
Good luck with what you're doing. We'll leave it there.
Thank
Thank
you,
you.
Nigel. Much appreciated. Bye.
Bye.